In this video for section 9.2, we're going to talk about how to test a hypothesis about a proportion. The basic concepts are pretty much the same as those for means. One of the major differences is that the null and alternative hypothesis, we will use p instead of mu because we're talking about a proportion instead of a mean. So we're going to look at example 9.9. It says a basketball team is considering raising their ticket prices, but the marketing manager does not want to implement the price increase if more than 10% of season ticket orders would be canceled. A random sample of 100 ticket holders found that 14 would cancel their ticket orders if the price change were implemented. Is it possible to conclude at the 0.05 level of significance that more than 10% of the season ticket orders would be canceled? So our random sample is 100 ticket holders, and 14 of them would cancel their orders. And our claim here, or our question is it more than 10%? So is proportion more than 10%? So that's our claim. And that means that our alternative hypothesis is going to match that. So our alternative hypothesis is going to be that p is greater than 0.10. And our null hypothesis is going to be the opposite of that. So our claim leads us to our alternative hypothesis. Null hypothesis is the opposite, so p is less than or equal to 0.10. So this is a proportion problem, so we're going to use one proportion in Minitab. So we're going to go to Stat, Basic Statistics, one proportion, and we have summarized data. So our number of events is going to be the 14 out of 100, which is going to be the number of trials. And we are going to check the Perform Hypothesis Test box. Our hypothesized proportion from our hypothesis is 0.10. Then we click on Options. I don't need to worry about the confidence level box. I do need to change the alternative hypothesis box. My alternative hypothesis is that p is greater than 0.10. So I need to change this to proportion is greater than hypothesized proportion. Our hypothesized proportion is 0.10. That's entered on the previous screen. Then we need to change from exact to normal approximation. And we need to do this whenever we're doing one sample proportion to help us get correct answers in MyLab. Click OK. Click OK again. And here are my results. Scroll down toward the bottom for the test results. I see my null and alternative hypotheses written here, and I have a z-value and a p-value. The z-value is something that you will need for some of the MyLab problems. The p-value is what tells you whether or not you reject the null hypothesis. So my p-value is 0.091. So that's what I actually need here. And when I'm doing my determining whether to reject or fail to reject the null hypothesis, I'm comparing the p-value to the alpha, or the significance level in the problem, and that is 0.05. So the question that I need to ask is the p-value less than alpha? In this case, no, the p-value is not less than alpha. The p-value is bigger than alpha. So since p is not less than alpha, that means we cannot reject, or we fail to reject, the null hypothesis. Now, if the alpha here was 0.10, and you may see that in some problems, then we would reject the null hypothesis because the p-value would be less than alpha in that case. But in this case, the alpha that we're given, the p-value is not less than alpha, so we fail to reject the null hypothesis. And since we fail to reject the null hypothesis, that means we do not have evidence to support the claim, or we do not have evidence that more than 10% of season ticket orders would be canceled. So our conclusion is that we do not have evidence, or sometimes it'll say sufficient evidence that more than 10% of orders would be canceled.